Try to find a seat to sit down. We would prefer you didn't stand by the door because you're close enough to those sensors that you may not get credit for the class. There's quite a few empty seats. There's a few scattered out here. If you can scoot in from the edges towards the middle, that'll help. There's still a few people in the back. Again, try to find a seat. We don't want you standing by the back door. Mr. Stewart. What's that?
They're going to sneak out.
Yeah. What's that? And we'll ask you to close that door too, please, if you would. From the inside. There you go. Outside. Okay, welcome. It's time to get started here. Again, by coming through we still got people coming in. By coming through those stations on the outside of the door there, your attendance is automatically recorded, so and you have to be in the room for at least 35 minutes to get credit for the session, so just make note of that if you need to go out for a few minutes. We're going to give we've got two presenters today. We're going to give them the full time, and then we'll try to stop them about 5 minutes before the session's supposed to end for any questions. So hold your questions till then unless they ask for questions. This session is the bridge inspection basics. The description of the session is the structural steel inspectors perform inspection on structural steel materials, welding, and structural coatings. They perform specialized sampling and testing of materials and analyze their physical and chemical properties to verify compliance with standards and to ensure that quality products and materials are incorporated in UDOT structures. The learning objectives for this session is an overview of those services provided, direction on how to request and involve Central Materials Structural Steel inspectors on in-shop and field inspections, identify some common issues found in the field and in your field inspections, and a specification overview, and then identify resources available for questions and clarifications of plans. Our presenters today are Mark Allington. Mark is a Utah native prior to joining Project Engineering Consultants, PEC. For 5 years ago, Mark worked at the Utah Department of Transportation for 30 years. He spent time in materials, survey, and construction inspection. He holds multiple certifications, including WAQTC, CCT, SRD, TT, NHI safety inspection of in-service bridges. He will be our first presenter, and then after him will be Jeremy Price. Jeremy Price is a Utah native and has worked at UDOT for 22 years. He worked in the department welding shop for 2 years, and since 1997 he has worked in Central Materials as a structural steel and coatings inspector. Jeremy has over 30 years experience in structural steel fabrication. His certifications include AWS Certified Welding Inspector, ASNT Non-Destructive Test Inspection Level 2 in Utah and Montana, and 2R Radiographic Interpreter, also certified as SSPC Bridge Coating Level 2 Inspector and SSPC C3 and C5 Supervisor / Competent Person Training for De-Leading of Industrial Structures. That was a mouthful. we're going to turn the time over to Mark, who will be our first presenter, and just go from there. I'll give these guys a round of applause, please.
First off, I want to, thank UDOT for asking me to do this. I don't know. As Jeremy and I got together and was talking about what we were going to do and everything. Oh shit! All right, so as we got together, can you hear me? How's that? Oh, there's working. Okay, so as I like it better like this anyway. All right, so as Jeremy and I met to kind of talk about what we were going to do and what we were going to present on, I guess 15, 20 minutes each. It's pretty hard to go through the full inspection of a structure from beginning to end. And so what I've got here is just a few things that I've found over the years that sometimes get missed or people have questions with about what's critical to look at in just a few of the aspects of bridge construction. Jeremy will take care of a lot of the welding stuff that I'll touch on, but I'm not a welding inspector, and that's definitely when you need to call Jeremy and get him out and his guys out in the field to help out with that stuff. So round piles, gosh dang, round piles and H piles, the specification section. That's the other thing I wanted to mention too is any time that if you get assigned a structure, as soon as you find out that you're going to be the inspector, I would highly suggest getting the plans and specifications and start studying them. There's so much contained in the plans on a structure, in notes and everything else that you can't, at least I've found, for me, I can't just go out and show up and expect to know what the hell I'm doing. I need to study quite a bit, look at all the sheets, look at all the notes, definitely read your notes on everything so that I have an idea before I even get to the field kind of how things are going to progress and what the contractor's required to do on specific portions. That one better? Okay. So round piles, H piles, standard specification 2455. First thing you'll have is your survey. They should set you out offsets for your alignment. Then you're going to be checking your plumbness. Most of the time, you're going to have splices on your piles depending on what the embedment depth is and what size piles the contractor orders. Talk a little bit about driving criteria, PDAs, and then we'll talk about the rebar cage that goes in round pile. In all your plan sheets, you'll find a table similar to this, and it gives you a lot of information off of the survey that you get for your alignment and elevations. Sometimes you're driving pile in a footing, or a lot now we're driving our piles and we're leaving them standing and then building MSE walls around them. And so in here it'll give you estimated pile length. Now that's from cutoff all the way to depth. A lot of times that's not really going to tell you how far you're driving that particular pile, especially if you're building an MSE wall around it. And so you need to do some basic elevation checks to have an idea of how many feet you're going to be driving that pile And then you can look at your bore logs to see what you're going through. So you kind of have an idea of really how the driving's going to react, and as you're doing your counts on your pile, if you start hitting a hard layer and you're way above your minimum or estimated tip, you can be pretty much assured that you're not going to overstress the pile and you're going to break through the lens or whatever is happening out there. Bore logs it's a good thing to look at to understand what the subsoils are, but I've been on projects where they've had bore logs and we're 50 feet away, and because of the terrain and everything, the bore log wasn't really even remotely close to what we were driving in. And so as the hammer is driving pile is not something that you can just sit in your truck and say, yeah, it's getting done. You need to be right there on site watching what's happening with the hammer, with the piles, and everything that's going on, so that between you and the contractor you can decide, hey, we need to hold off and get the geotechs in here to see what's happening, so that we're not overstressing piles and then assuming that the pile is good and the capacity is sufficient for the structure in the end. This is again on the piles, and I talked a little bit about the minimum and estimated tips. But in this one, I just really wanted to show it, and it's not very good. In here, these are H piles. We built up a bin wall for a temporary abutment, and H piles over there. The way the H pile is set in an abutment or a footing is critical, and the contractors know that, but I've been on projects where the pile buck turned the H the wrong way, and at that point, the capacity that the designers have designed for that structure is totally blown out. So as you're looking at your plans, make sure you're looking at the orientation of the H in your H pile. And thank you, Julie. And even though pile bucks are interesting folks, just make sure that as they're starting to set, the first, this is just H piles, and they have a few different things that you got to look at on that with their driving shoes and stuff. But just like with this one, those H piles, if you went off of minimum tip and you had your elevation down at the bottom and you didn't calculate that out to cutoff, and the contractor's got people that are calculating that too, but just so that you know how many feet into the ground your minimum tip is supposed to be. On alignment of the piles in line where they're supposed to be, the specification goes through a lot of different criteria, and this is one. When you're starting pile, you need to make sure that they have a feather flag at center of pile location, and as they're setting that pile down, be there with the pile buck and the crane operator to make sure that that pile is centered as closely as you can to that feather flag, because they should not be more than 6 inches in any direction off of exactly where a survey is shown that. And depending on the soils that you're driving in, as soon as they start driving, whether especially if it's rocky, sometimes real soft soils, it'll walk a little bit. But for that first 15 feet, you need to be really checking that pile, that it isn't moving, sliding, on H piles, that it isn't twisting. And there's a whole lot more in this spec, and that's why I say when you get a assigned a structure, you need to get on it as soon as you know, so you can start reading through all this stuff and get this stuff in your head. Not that you have to remember it all, but at least you know that there's something there that I really need to be checking, and refer back to the spec, the plans. The plumbness, that's another real critical thing as you're driving, that you have to check as you're driving to ensure that the plumbness, 2% of the total length, and then the 1/4 inch per foot, or the 0.6 inches and 30 inches. You need to be checking that as you're going down, because that says through the total length of the pile, right, in the spec. And so you get a round pile down there and you cut it off at a foot above grade, bottom of footing grade. How can you assure that as it was driving down, it didn't hit a rock and start kicking out down below? So as you get started driving, the contractor will have a level there. Be right there with them, watching that level. They'll strike it a few times, get it down 4 or 5 feet, double check it, till you're about 20 feet, and after you're 15, 20 feet, there's nothing you're really going to be able to do to straighten that dang thing out. So that first little bit as they're driving is real critical for you to be right there with them to watch that, so that you have pretty good confidence that as it's going down, you're going to have that plumbness throughout the entire length of the pile. Once they get it down, and I got a slide here that shows another way that you can check for alignment and not really plumbness, but you can always mirror your round pile to see if you can see the bottom, if there's water in it, before you place concrete, to do a double check to make sure that, again, the capacity of the pile is going to be there. If there is a problem, you can get the geotechs out and the engineer record out to look at what you got and do some recalculations or whatever. On splices, like I said, I'm not a welding inspector. I can look at a weld and say, you know, that looks like pigeon shit, or it looks like a decent weld, but I really don't know what I'm looking at on a weld, and that's when I get a hold of Jeremy. He sends Nick out or somebody out to look at the welds, kind of show me what to look for. If the welding that the pile bucks are doing is a good weld, if they have problems with it, look at their certifications and tell me if there's some things I really need to be looking for on the different splices. Same thing on the bottom plates. There's welding criteria on the bottom plates that need to be looked at. They'll have a detail in the plan on all of that, so that you know what bevel they're supposed to be putting into the pile on the bottom plate and all that to weld it. But again, if you're not a certified welding inspector, I would highly suggest getting a hold of Jeremy and his team to come out and give you a hand. And they're always happy to come out and help out, and even, you know, do a little teaching of what they're looking at and what, as an inspector, you need to be looking at. And if you do have questions, call them back and they can come look at it. Now, after the first pile is driven, the PDA must be completed, 1 per abutment or footing. This is supposed to be happening on the first pile as it's going in. In reality, what the contractor usually does, because he has a lot of iron out there, he has his crew out there, they don't want to just drive 1 pile, wait, set up, come back, do the retap, all that stuff. So most of the time what I've seen happen is they'll drive the first pile, and I always let them know, you know, if that's what you want to do, okay, but you're on your own, because you're kind of going against spec. They want to keep their equipment busy. They're there to make money, and I understand that. They'll continue to drive that abutment or that footing as much as they can for a full day's production, And then knowing that, they're coming back the next morning with the geotech engineers and running a complete PDA on it to get a driving criteria. But as you're doing the PDA, for me, I've always liked to be right there with the geotechs when they set their sensors, help count the blows per inch for them. And then what's really good now is with the technology we have now, most of the time they can calculate that right on site and give you a driving criteria, and then you can just continue on. But again, that's not for the whole structure. That's for that one, that one abutment or that one footing, because you have to do that each time you start a new abutment or footing, because the soil conditions could change. And that's just, again, all about capacity of the pile, so that in the end our structure is gonna be able to function as designed. This in here, after the piles have driven, and this kind of takes up a couple of deals. Rebar placement in the round pile. As you're placing the concrete, that pile, because they'll run a solid trimmy down through the center of the rebar to get down below the rebar, and so you don't get segregation and everything going down into your pile. As they're coming up, you need to make sure that cage is centered as perfectly as you can possibly in the pile. A lot of time it'll slide over and butt up against one side of the pile. They're going to have to do whatever they need to make sure that cage is centered, again, to transfer all the loads down through the pile like it's supposed to and get full embedment of that pile. Once the forms are up, they'll come in, resurvey the forms. This is another time you can check for your alignment, clearance off of your forms, to make sure that those piles are where they're supposed to be. If the piles are too close to the edge of footing, out of alignment, again, that goes back to capacity of piles not being achieved, not being in the right place, so the load transfers through the structure down into the earth like it's supposed to be. On the abutments, reinforcing delivery and storage, that's a big one that I see a lot of times get overlooked. They'll bring out the flatbed and just start dropping rebar in the dirt, mud, throwing shit on top of it. Rebar placement, concrete placement, and then bearings on your abutments and stuff is a huge deal, I think, that many people don't pay enough attention to, because they figure out it's just a piece of rubber up there that just has to be there, and it's not just a piece of rubber. Again, recheck your piles after the forms have been placed. This here is picture, pretty good storage. They got it up on dunnage. Their tails are down here in the mud, which ain't good. But for the most part, they've done pretty good. They've got it up off the ground out of dirt. In the specification, it talks specifically about storage of rebar on site, and it talks about mud, dirt, all the elements that can cause damage to the rebar. And if we're not watching this, of course, and I got some slides in here that show some damage to coating, and that coating gets damaged and is not repaired properly, it's taken away the life of our structure in the end. So this is something that is a lot of times overlooked, and the contractor doesn't most of the time see the necessity of it, because it's a pain for them to go around and find dunnage to make sure it's up out the ground, make sure that they're not piling other construction materials on top of it. The supports, they got some dobies there, different kinds of chairs. that can be used. One of the big things that I see also is a lot of rebar companies will come out with just chairs that are to be used on formwork, and they try to put it in a footing or an abutment on the dirt. Then your bottom cage drops, and in all your bottom cages and all your bottom rebar, if you are placing it on dirt, it needs to be adobes or something with a sand foot on it, like these ones, so that chair and everything doesn't sink, so that you have your proper clearance on your tension bars on the bottom, right? Because that's where the rebar is doing its major job, is on the bottom in that tension area. In between mats of steel, like on approaches, not so much on decks, but footings, abutments. A lot of times the contractor will try to stack dobies in there. That's unacceptable. They'll try to stack chairs on top of each other, unacceptable. They need to be using rebar chairs that are bent to the proper distance. A lot of times they'll try to go and makeshift some, bend them. Again, then you have rebar in there that's not coated that will eventually rust and deteriorate our structures. This picture over here is showing like up against the form, they'll put the bottom chairs in, but then they won't chair up against their form, and so your clearances on your walls a lot of time are not achieved, and they'll get it up, you'll go back to do your inspection, and then instead of having your 2 inches or whatever is called out in the plans, you don't have your proper clearance, and then they want to fight you to get down in there because they have to undo rebar, get down in there, chair it out. So it's just another thing that I found that works well for me, is to get with the contractors before they start standing forms or setting rebar, and make sure that they know proper clearance, that you are going to be looking at it, and they need to chair all the way up the forms, so that you don't have this situation right in the left slide there. These are just some good pictures of proper rebar placement. At least I believe on this one here, they got their strip chair all the way along the form, tied on, so that they've got their proper clearance on that. They're using those are just tops of abutment bars, the U bars on the top to get their clearance there. They have not set the back form. Once they get that all tied up, you can do a really good inspection before they set that form of all your ties and making sure that everything's proper. They set their outside form up with the chairs already attached, and then you know that everything's good. On this footing over here with your uprights coming out, they've got all those secured so that as you're placing, those things aren't going to be moving around. They're in the proper location. This is really important, like on bent caps that you're doing a bent diaphragm right on top of your bent cap, where your girders are coming in between some uprights, so you're not having to go in and bend your uprights, cut them, redowel them, because again, it's just not needed. If they take care and do the job, and we do our job as inspectors to be checking measurements and clearances and stuff like that, everything should slide together just like it shows on the plans. On deck rebar, the one thing that I like to do is I like to stand off to the end, just sight down all my bars to make sure that they're within the 1/4 inch that they're supposed to be, and they don't have big wags going down their longitudinals or their horizontal bars and their transverse bars. Another thing on these, even though everything looks nice and consistent and you would think that your bars are in there, make sure you go out and you count. Do your rebar counts on everything so that you're not even missing, everything may look good, but they're short 2 bars. Well, then it's not built the way the designer designed it, And so now you're going against what the engineer of record has told you to do on the bridge, and if something happens with the bridge, it's your problem, not theirs. So I'll go out and I'll do just kind of a real quick visual, looking at all the bars, walk the whole thing, look at ties to make sure that they're 100% tied. If in any one direction is over the 9 inches, if it's less than, you know, in both directions, they can do 50%. You got to remember that's, you know, if it's 6 inches one way and 10 inches, 11 inches the other way, it's 100%. They don't like hearing that because they're, you know, it's just more work for them. And they'll say, well, we've never seen it move. It's going to be fine. Well, good for you guys, but this is what the spec says, and this is how it's supposed to be. The other thing on deck still, it talks about in the spec tying the top mat of rebar down. And you'll get shit every time you tell the rod busters to tie it down, because they'll come back and say that they've never seen a mat float, and they float. I can promise you they float. I've seen it. Brand new decks had to be removed because they didn't tie it down and the mat floated and they didn't have their clearance. So just make sure that they tie that mat down to Nilsson studs or to panel cables, whatever. Make sure that that mat is tied down. These are some pictures of some places like here. They got their foam. This is a really tight structure. This is on a deck. We've had to redo the parapet and the edge of deck. But they've come along and they've epoxied their bar into the existing deck. And it's obvious that a few of them didn't get drilled far enough and put in far enough. So there's a couple of problems here. Now we don't have our embedment or our reed bar for development strength on that bar into your deck. Plus your clearance on your center there is not complete 2 inches on your edge of deck. On the other side, it's pretty tight all the way along. And that's the other thing that's really important to, as an inspector, you need to be out there with a wire or whatever as they're drilling, checking every one of the holes. Just because they got a couple of holes that you've checked and they're good, you need to go through, even after if you want to let them go ahead and do it, go back through and do a quick check on all the holes, make sure they're clean before they place the epoxy in there, so that the epoxy makes a good bond to the existing concrete and the rebar, so you get that development that you need, especially on something like this where you're counting on that rebar to support that additional part of the deck, plus your parapet, any impacts that might come to that. This one here is just a quick shot of some rebar that was obviously damaged. There's a few of them in there. On these, contractor will come out with their green spray can, just spray a single coat over it and call it good. That's not good enough. We really should be making them use the 2-part epoxy paint, watching the cure time on the epoxy paint before they place the concrete. Again, you leave that little nick in there, that's just going to propagate through the rebar. I've been on decks that we've removed that, especially on epoxy coating, that it's amazing, but you can tell where the chip was, and it goes along, and all you see is the casing of epoxy. There's no steel left in the casing of the epoxy. The epoxy looks really nice and everything still, but there's no rebar in there. So this is something that, you know, gets overlooked a lot, that we really need to be paying attention to make sure that that this kind of stuff right here is not left unattended to before we place concrete over it. This picture here in the center is an abutment, an abutment diaphragm, and you can see that they didn't chair off their rebar here on this form here, because as they placed it, everything's shifted, and now you got, I mean, you're burning form right there on that side. So that, the things I'm showing you are just stuff that I see happen quite a bit that we really need to be paying attention to, because the longevity of that abutment with the rebar right there, you know, this one doesn't have a joint over the top of it. This one is just tied approach slab to deck with the joint out on the outside of the approach. But nevertheless, at that point, you're still going to have a cold joint. Water can get through there, and it's going to affect your abutment, eventually your bearings, and it's not going to give us the life that we need in our structure. Pumping concrete. Our specification says test the concrete at point of placement, right? And I know a lot of inspectors, oh, it's a pain in the ass to get out on the deck and test right there on the deck. There's no reason, like this picture, the contractor has no problem putting out some plywood out there so you can run your wheelbarrow out there. It's just real critical to do your tests at the end of the pump. With the new airs and stuff, you'll hear a lot of producers of concrete say, oh, the pumping doesn't affect the air with our new airs. That's bullshit. The angle of your pump, whether it's straight out, up, down, kink back, it affects it a lot. And so it's very, very critical that you, especially on decks, like this one over here with the column, I wouldn't suggest hauling all your stuff up to the top of the column. It's not safe. It's not safe for the workers. It's not safe for the testers, anything. But what you do need to do is you need to do some testing from same angle off to the side, from the truck to the end of the pump to see what air loss you're getting through the pump. And at that point, once you get a kind of a correlation between what's at the end of the pump versus what's going into the pump, I mean, just for safety reasons and everything else that goes along with it, you're pretty safe to use that correlation, that correction from end of pump to out of the truck before it goes into the pump and test there, so that you're not getting people hurt is the biggest thing. But on decks, abutments, most time on bent caps, they have enough shoring up there that's big enough and wide enough. You can use their man lift to get your equipment up there. You have enough room to be out of their way, test it right at the point of placement. And there's the sections on placement. The other thing I wanted to talk about is trimmies. A lot of times I'll see people shooting mud into forms. And of course, the contractor likes to do that because it's cheaper, because pumps cost a lot of money. But that's exactly what the spec says about free fall and when a trimmy is needed and when it's not. And it's, I don't know, it's very important to make sure you trim your concrete, because if you pour it over just start dumping it in, not only are you dropping it too far, but you're hitting all that rebar that's in there, and the segregation is just incredible. And so you're not going to get a good, cohesive, consistent mix down throughout your entire placement. It's just something that, for me, I keep a good eye on, and again, the contractors hate it when I bring it up and I show it to them. But if you study your specifications and everything, you know exactly where to go and say, no, here's what you guys bid. Here's what you guys said you would do. And then most of the time they will relent. Okay, here's some bearings. The one on the left, obviously, that bearing, even though it's new construction, that bearing's gonna fail. Bearings need to be placed and really watch closely. This one here, you can see all the writing here on the outside. It's centered, it's squared. You got good bearing top, bottom. That's how it should be done. This one here, there's so many things wrong with it. All your information, who knows where it is. That information, it may not seem like it's a big deal, but for central structures and stuff, they go out, they have to go and do inspections every 2 years. And without them being able to see that information, if a bearing is failing, they can go back to test reports and everything off the information that's on that bearing and see what happened and why, and try to come up with why, if it's just one bearing's failing. This one over here, it's already, I mean, it's so bad. It's not centered on the pedestal. You know, it's not bared top bottom. It's bulging on the side. It's kicked offset. I mean, that structure is doomed from the very beginning. So even though it doesn't seem like it's an important step, it's a very critical step to make sure that they're placed right for the longevity of the structure and the way it's supposed to be done. Here's some other ones. This one here again is placed correctly. This one is a bent coming through the rebar. Got your diaphragm, but your bearing pad is sticking out to one side. That should be flush with the edge of your girder like this. And so again, improper placement of bearing has an effect on the long-term performance of the structure. And then I guess we're going to have questions after, so, go back. I've mentioned this before. If there is any questions on the design, on what's going on the structure, if something isn't working on the structure, if you get out there and the design is showing you to do it a certain way, but it's not working that way, you got to get a hold of the engineer of record. They're the ones that have the stamp. They're the ones that have said, if you build it this way, everything's going to be fine. If you change one little thing, the liability is on you, not on them. And when bad things happen on structures, people die. It's not just an oops. And so that's why I'm very passionate about structures. I love structures. I enjoy them. And, you know, if there's anything that I can do to help anybody out, you can give me a call. Love to be able to help you out, talk to you, and I'll send the rest over to Jeremy.
Must not have been any other things going on. This thing is packed. All right, I'm Jeremy. I'm at Central Materials. There's three of us that actually work in the steel section of Central Materials. Myself, Nick Romero, and Lon Smalley that comprise the steel section. So if you guys are putting up a structure, it's really good to get in contact with us before everything gets rolling on it. The few things that we're going to try to get out of this is the bridge erection process itself, structural fasteners, coatings, and then some of the issues we've dealt with deck removal. Some of the things that are required on bridge erection submittals are the erection procedure itself, which actually has to be approved by the engineer of record, bolting procedures, field welding certifications and the WPSs. And then we will actually come out and help with the pre-bolt inspection. So with the erection procedure itself, we still have problems putting bridges up. Just because they put in a procedure doesn't mean everything's going to go as planned. We get out on the projects and they're bringing in bridge girders, and occasionally we'll have one roll over on us, and thankfully on this one no one was hurt. So in that procedure, it'll tell you locations of the cranes, how they're going to secure the girders themselves before they set them, any overhead obstacles they have to deal with, wiring, anything like that. The big thing to remember here is not to get underneath the girders, stay out of the way. Also in the procedure, it'll talk about once they get these in place, how they're going to get them safely and hold them down so they don't have any issues with them rolling over. This one, they actually balanced that girder on top of the bank cap there. It's kind of crazy. Didn't look like it was very safe, but they had it fastened down, chained down, and we didn't have any issues with the erection. This is when a bridge girder setting actually goes wrong. This happened in Colorado. They actually had a erection procedure turned in, but I don't think anybody looked over it. They had some inclement weather come in during this girder setting. They bolted in to the existing structure, which was an older structure, to try to safely hold it. They basically let go of it with the cranes and everybody went home. It only took about half an hour, 45 minutes. The inclement weather came in, wind started blowing, and this girder rolled over and basically laid flat down on top of the freeway. And unfortunately, there were 3 people that lost their lives in that one. Vehicle coming through there actually hit the girder itself. So this kind of stuff does happen, but with the procedures, hopefully everybody looks over it. It's been bought off by the engineer of record, and we follow it, so this kind of thing doesn't happen. Next thing we'll talk about is bearings. So when I know Mark touched the base a little bit on this, and we'll go over it a little bit more. One of the big things with bearings is getting them placed properly, also cleaned off. The bearing area, the surface areas, they're cleaned off, all the rocks, everything. It's kind of funny, we go out and we go out and check them, and a lot of times there's gravel and everything underneath the pads. And we start asking them to pick up the pads, move them, clean them off, and also wipe the bottom of the girders off, and the guys get a little excited about it. But unfortunately, if they don't do that, the gravel and all the debris underneath those bearings will eventually wear through the bearing surfaces, and the bearings will fail. This one, the survey, there was a bust in the plans, and when we called and asked if the survey had been done, they said it had been and everything was right on. Well, we got out there and set the girders in place, and this is what we end up with. This girder bearing stiffener is supposed to line up right here. Of course, you can see the bridge isn't short. There was a bust in the plans, so they ended up coming in and putting a new stiffener in there. Okay, so this is what the elastomeric bearings look like. There's vulcanized rubber in between these, each steel plate. So one of the things that we're concerned about is when the welders are out there and they start welding these girders down, is that they don't exceed 200 degrees. Because at that point, the elastomer will lose the vulcanization to the steel plates, and they'll separate, and then basically we have another failure in the bearings itself. So you can see somebody got a little excited with the hammer, beat the ends of the bearing up, and once they do that, it will fail, because not all the metal plates are stainless. Sometimes we'll have just regular steel in there, and if that's the case, they rust, and then they will lose the bond once they start breaking down. I think there is like a 60-day lead time, so once you find this on your project, you got 60 days before you're going to be able to get girders or the bearings ordered and into the project. So when they do arrive on the project site, you need to make sure that they're handled correctly and they're not just tossed around. Usually we like to see them covered up and left on their pallets until they get placed. So the bearing area, you can see that this one, nobody looked at it. Actually, this is when we removed a deck on it. During the deck removal process, nobody happened to go down underneath the bridge after the deck was taken off to check the bearings. Everybody was excited. The deck came off. We didn't have any issues. They formed it and started pouring, and one of us happened to go down and notice that the bearings, nobody had checked the bearings, and you can see the gravel in between the rockers here. They ended up jacking everything up, stopping what they were doing and cleaning these bearings out. It was a 5-minute check. If somebody would have checked the bearings before they started placement, we wouldn't have had this issue. It would have been real quick. They could have lifted them up and blown them out with probably compressed air and got everything out of them. There's another issue we deal with. Mark talked about the markings on the bearing pads themselves. So not all the bearings are the same size. And one of the reasons they are marked is so that we can identify where they're supposed to go in the structure. Occasionally, somebody will get busy putting bearings in and not checking where they're supposed to be put, and they'll get put in the wrong place. This one happened to be that the center bearing, there was a bent, and the bearing was actually, they put the wrong ones in it. And when they set the bridge on top of it, because the wrong bearing was set in there, it's too thick, you basically end up with a floating girder. As you can see, there's a space in there. That's not supposed to be there. What we ended up doing is go back and jack the bridge, pull out the bearings, and put the correct bearings in the right place. The other thing, like Mark said, is the location, also identification of the bearings. So if there is a failure in that bearing, we can go back and locate all the test reports and everything on this bearing for the marking. And when we go out on the bridges themselves, everybody gets excited because we, well, make sure the writing's facing towards the center. And of course, the guys out there don't understand why. But for us, it's a big thing. That way, if we have an issue, we can go back and look at the test results on the bearing itself and find out why it failed. Structural fasteners. In the submittals, they'll have a bolting procedure that's required to be submitted. One of the things in that bolting procedure they talk about is storage of bolts. As you can see here, it's pretty dusty on any of the construction sites. We deal with the dust. These bolts are all coated, and they actually have to be enough oil on them so that when you touch them, you get oily hands. They have to be oily to the touch. So what happens in an area where there's a lot of dust, of course, it gets stuck right onto the bolts themselves. It doesn't impact anything until you go to start installing these bolts and doing rotational capacities. So when we come out on the site, we'll check the storage. These should be in an area that's, controlled to where they're covered up and there's not a lot of dust. We'll come out and do a pre-installation inspection, which basically you put a bolt assembly together in Skidmore and tighten it up, and we'll check to make sure that we'll meet the minimum tension, and then also that each component of that assembly is put in the right place. This is also a good thing to go through with the bolting crews themselves. That way we can catch them right at the very beginning to make sure that all the bolts are going in correctly. Because we use the DTIs on all of our bolts. We don't use TC bolts. We use DTIs. As you can see, this one is actually upside down. Anybody that's ever worked with these knows that the dimples on this washer are supposed to go to a hardened surface. In this case, they were installed incorrectly. And once they start tightening these bolts up, those dimples actually go down into the steel. This is a hardened surface, the washers are, and of course the steel is soft, so they just penetrate down into the piece itself. So during that installation procedure, pre-installation, we can figure out what's going on and let the guys know, hey, these aren't the right places for these to go. During the process, after we've gone through the bolting procedure, set up with the guys, normally what we do when they start setting girders, we'll stay in with the bolting crews and actually go up while they're installing the bolts and watch them install them, tighten them up and get them the right tension. Make sure that going forward right off the bat that all the guys know how tight we want them so that we don't have to go back and tighten up bolts after the fact. The other thing we'll do is do a splice certification. And what this splice certification basically says is that all the plies were pulled together in firm contact before they were the final tightening of the bolt. We'll go through with whoever's out there and show them the documentation and tell them kind of how this is supposed to work. If not, we'll do it ourselves. Most cases, we're the ones that go through and do these. We'll sign them off and buy off each splice as we go through the structure. So this is actually supposed to be done before the deck is placed. As you can see, we've got an issue here. These bolts were installed, but there's one missing. So most of the time, most bolting experts say that you can't over-tension an A325 bolt. Well, I happen to disagree with that. This structure was actually put in place. Everything looked good. The bolts were all tightened. We go back a few months later and we're missing a bolt. Basically, it was pulled to right at its yield, and then through it deflecting after the deck was put on, it basically broke the bolt and fell out after. So when somebody says you can't over-tension the bolts, that's not true. It can happen. It can happen, and they won't necessarily break either. So after the deck's up, you get a hold of us, we'll come out, and we can help do the studs, stud welding. Actually, there's a procedure that has to be performed before they start to make sure they're doing everything correctly. OSHA about 10 years ago decided that this was a trip fall hazard, so they said these have to be installed in the field rather than in the shop. Before they were done in the shop, it was really easy for us to look at, and nobody had to worry about it. Now they're done in the field, and so somebody's got to be there to basically watch it. The important thing is, after they do the actual installation, the procedure itself, going through, they'll weld a couple to the top of the girders. We'll bend them over to make sure that they're not breaking, and then we'll let them go. Big thing is to remember is those guys need to break the ferrules off on the bottom of these studs. It's a ceramic ferrule that has to be there. Once it's installed, they can knock that off. We've gone through several decks where the guys haven't broke off the ferrules. They've basically just put 1,000 studs in along the top of that girder and not broke the ferrules off. But walking across the deck, you happen to catch your foot on one of those studs and it just pops off, which is a bad thing. They're not supposed to break off that easy. So you start breaking off the ferrules, knocking them off, and you go through the whole thing and find out that I think there were 500 studs that weren't welded completely. So they had to go through and break them all off and reinstall them. And unfortunately, they had to wait to get the studs in because they didn't have any at the local hardware store. They had to order them in. So we'll go through and check all of them. Walk through with a hammer, usually a 8-pound sledgehammer, and sound each one. A good welded stud will have a ring to it. One that's not welded will have kind of a thud to it. So if anybody wants to check studs, they're more than welcome to come out and try it with us. Get your arms worked out. The other thing is during the stud welding process is to make sure that the stud welder is grounded to the work surface in an area that is not primary member. So typically we like to see them on a cross frame or something like that that's not going to be, if it does short out, that it's not going to cause any damage. This was actually on the bottom flange of a girder. They had gone through and welded a bunch of studs. This was an existing structure. After they got finished, they went to pull the ground off and noticed the ground was stuck to the bottom of the girder. And this is what it looked like. Basically the size of a quarter, and it went into that bottom flange about 3/8 of an inch, which for a welder, welding overhead's not easy, and to clean that out is even worse. So they ended up having to grind that out, and a welder had to come in and weld overhead to patch that and fix it. Of course, we had to go through the engineer of record to make sure everybody was okay with the fix, and then they also had to do a welding procedure, a repair procedure, and have that sent in and okayed. After that's all done, we can come down and help do the coatings. All three of us are certified coatings inspectors. We can come out and kind of give you guys a hands. I know we have a lot of equipment that most of the people don't have for checking thicknesses of coatings, for checking the environmental conditions, all of that. So once the deck's put on and the forms have been pulled, we'll come in, they'll power wash these girders off, and then they'll put the intermediate and prime coat on intermediate and top coats on. This time of year, we usually struggle with the painters. I know everybody's trying to close out get their projects done, completed before the end of the year. Unfortunately for the painters, they're usually the last guys to go out. And as all of you know, it's getting cold outside, so we're dealing with 40-degree temperatures. 40 is the minimum they can paint outside, and then we've got dew point issues. So we'll come out, use our instruments, basically leave them out there, they're babysitters, kind of keep track of the guys, make sure that they're not painting outside those limits that are in the specifications.
Jeremy? We've got an hour before lunch. This is the last session before lunch. Let's just go ahead and give him time to finish up. And I don't think that's going to affect your lunch, so just be patient.
We also do lead removal. This is basically just a typical lead removal project, basically removing the paint, regulated areas. They'll go through and remove all the paint to an SSPC SP10, which is near white, and then they'll prime it, intermediate, and top coat. I'm going to try to hurry. This is a typical overcoating systems. You can see the red lead actually on that. The specification requires that any areas that are peeling or lifting have to be sanded off and faired out. And what you can see here is the painters have gone in and sanded this down and then faired it back so it's smooth and it's not lifting. Typically if it's not done properly, when they start painting it, it actually lifts a day later. And this is what we end up with, something like this. The paint will fail. It won't take very long and we'll start having issues with the paint failing. It just basically falls off. Deck removal on steel bridges. Concrete, we don't really deal with the concrete removal on concrete girders, but we do on the steel. Some of the things they need to turn in removal process procedure to make sure that they have, once they've got everything under control, all their procedures are turned in and bought off by the engineer of record. And if it also requires to have welding procedures and repair procedures in that. I think out of the last 10 years, I've only seen one bridge have the deck removed that didn't need a repair, basically. So as confident as most contractors are of pulling those decks off and how everybody thinks it's really easy, it's not. It's not. So the big thing is make sure their procedures are in and make sure they follow their procedures. This is an incident where we had them cutting the deck basically into panels, and they got into the top flange of the girder. We had to come in and have that gouged out and full pen welded, and we had to do the ultrasonic testing on it and everything else we would typically do before they could get moving. This probably holds them up probably 3 or 4 days at least. So on a time-sensitive schedule, that can really put a crank into things. This is one where they've used the excavators to pull the top of the deck off. And as you can see, one of those impact heads got into the top flange, and they had to come in and fix that. This is a typical damage that you see when they're tearing the decks off. One thing you can go is underneath the deck and look up the top flanges. And if you can see the sunburst area at the top, like that's actually the bottom side of the top flange. That is where one has been impacted. So once this has happened, we'll go up and check it, do some dye pen or some mag particle testing to see if there's any cracks. And hopefully there isn't. Unfortunately with this one there was. As you can see, it's actually separated at the toe of the well, the top flange from the web. What we had to do with that one, come in, they actually had to lift that girder up, take all the pressure off of it, all the load off of it, come in and cut it out and put a panel in there, weld it in full pen welds, to do the repairs. That's it. So the biggest thing for this is to know who to contact, who to call. You can get our information after this, or we're, of course, on group-wise for contact information. Is there any questions?